Hello everyone, welcome to Pepcoding. In today's video, we are going to look at the question boats to save people. Okay, so let's take the problem statement. Okay, so it is saying that you are given an array people where people I is the weight of the ith person. Let's say I have this vector and every single element here is representing the weight of someone. Okay, so you have infinite number of boats where each boat can carry a maximum weight of limit. So let's say I have a limit of 14, right? And I have infinite number of boats. I have infinite number of boats, and every single boat can have the maximum limit or the maximum weight limit of 14, right? Every single boat has a maximum weight of 14. So each boat carries at most two people at the same time, provided the sum of the weight of those people is at most limit, which means that this boat can carry at most two people, right? Every single boat here can carry at most two people, but provided that the sum of the weight of these two people is not greater than my limit, right? It should be less than or equal to my limit. So let's say I have 6 and 2, right? I have 6 and 2 here. The weight of the combined weight of 6 and 2 is 8, right? Which is less than my limit. So I can have these two elements, these two people on my boat. Let's say I have 7 and 7, right? 7 and 7. Now these two people have a combined weight of 14, so they can also go on my boat. Let's say I have one person here with weight 11, right? Now the weight of this person 11, or let's say I have, or let's make another element of 13. Okay, let's say I also have a 13. Now this 13 is here, right? Now I cannot pair this 13 with anyone else, right? This is my largest number here, and I cannot pair this 13 with someone else without exceeding the limit. I can pair this with 10, but it will exceed my limit. So I cannot pair this 13 with someone else. So these are my valid uh, combinations, right? So I can have this number of boats where I can have these combinations. So it is saying that return the minimum number of boats to carry every given person. It's saying that we have to return the minimum number of boats that we will use to carry every single person here, right? So what we have to do is we have to put every single person on a boat here, and we have to use minimum number of boats. We have infinite number of boats, and every boat has a limit of 14, right? And if we are putting two people on the boat, we can put the maximum number of people, max people that can go on a boat is 2. The minimum people or the min person is 1, right? I can only have one single person on a boat, or at most two people on the boat, right? And their sum should be less than or equal to my limit. This is the condition. Okay, so this is my question, and I hope you understand the question. Now let's discuss the approach. Okay, and let's discuss the brute force approach. What is going to be my brute force approach? Let's say I have two pointers, I and j, right? For let's say I is at 7 and j is at 9. Assuming that I've already put 7 and 6 on a boat, 2 and 8 on a boat, right? I've already put these two pairs on my boat. So, right, 7 and 6 gives me 13, and 2 and 8 gives me 10, and so they can go on the boat together, right? Now, we have 7 and 9. Now, for 7, we will check for every single element, right? We will check for every single element. What we are doing is we are taking an I, right? Let's say my I is at here and my j is at here. The j will traverse through every element on the array, and it will check that can I pair this I with this j, right? It is checking that can I pair this I with this j without exceeding my limit. If I exceed my limit, then it means that these two cannot go together on the boat, right? So what am I doing is I have, let's say I was here, right? I've paired these two already. So I is here, j is here, right? Now 7 will pair up with 9. It will see that my weight, my total weight is 16, right? 7 plus 9 gives me 16, because it is 7, 8 and 9, right? 7 plus 7 is 14, 15, 16, right? So 7 plus 9 is 16. Now it is greater than my limit. Now 7 plus 8, my j will move forward. 7 plus 8 gives me 15, right? It is also greater than my limit. 7 plus 11 gives me 18. 7 plus 10 gives me 17. 7 plus 13 gives me 20. So there is not a single option where I can have 7 pair up with anyone else, right? I cannot pair this 7 with anyone else. It means that this 7 will go alone, right? Similarly, this 9 cannot pair up with anyone else, but it will check for the rest of the array. So in my brute force approach, I'm traversing the whole array for every single element. For every single element, I'm traversing the whole array to find someone to pair up with. And if it doesn't, then I can simply say that this element is going to go alone, right? And also, let's assume that 7 was paired up with 2, right? And I'm checking for 6 again. So if I'm checking for 6, uh, when I check for 2 again, 2 is now already included in my 7, right? 2 is already included, 2 has already paired up with 7. So this 6, this 6 cannot go with 2, right? So I will make a boolean visited sort of array which will mark true if the element is already included. So this is going to be my brute force approach, right? This is not a very optimized approach, so we have to optimize it in some way, right? So let's look at the optimized approach. Okay, so here I'm going to write the steps first, and then I'm going to discuss why we are actually doing the steps. Okay, so my first step is going to be sort the array, and my second step is going to be use a two pointer approach. Okay, so if I sort this array, I would get 2, 6, 7, 7, 8, 8, 9, 10, 11, 13. Okay, let's remove this 13. We don't really need this 13 because we added it later, right? But let's say I have this 13 only. So this is my array, right? And now, also my limit is 40. Okay, this is my sorted array. Now, why did I sort this array? And I'm also saying that I'm going to use a two pointer approach, right? So my two pointers are going to be I here and j here. Now, why did I sort this array, right? Do I really need to sort this array? I sorted this array because you can see that after sorting, at the end, the element at the end at this vector, the element at the end is the maximum element, right? I will have the maximum element at the end of this array or this vector, right? So 13 here is maximum, and if 13 cannot pair up with I, right, which is my minimum element in this array, because my I and j are going to increase and decrease, right? That is my two pointer approach. So in that subarray, I will have the minimum element as I, right? And if the maximum element here cannot pair up with the minimum element, then I can simply say that this maximum element is going to go alone on the ship, or is going to go alone on the boat, because this maximum element cannot even pair up with the minimum element, right? So this will be more clear as we parse through this once. Okay, and also we will see the three things we are doing, right? I will have the three conditions. Let's say my sum is equals to people of I, right, plus people of j. This is my people vector, right? This is my people vector. So people of I and people of j is going to be my sum, and I can have three different conditions, right? My first condition can be that my sum is going to be less than my limit, right? This is going to be my first condition, and I can have my sum be greater than my limit. right? Or let's say sum be equal to my limit. And third, as sum be greater than my limit. So I can have these three options. And in these three options, I'm going to do some decisions. Okay, so let's see. I have this I and j, and I will also have a count. Right? So let's make a count which will increment every time, right? Which will increment every time we find we use a boat, right? So this is my boat count. This is my boat count that I'm going to use, which will represent or which will tell me that how many boats I've used so far. Okay, so I have this I and I have this j. Now the value at I and j, or the sum, is now greater than my limit, which tells me that these two people cannot pair up on a boat, right? This 2 plus 13 gives me 15, which is greater than my limit, which is 14, which means that these two people cannot pair up, right? They cannot go together on the boat. So it means that I can increase this I, right? I can increase this I, but this will tell me that 2 is going to go alone, right? If I increase this I, it is going to tell me that 2 is going alone on the boat. But if I decrease this j, it will tell me that 13 is going to go alone on the board. Okay, this is what I'm saying. So if I increase my I, does it mean that 2 cannot pair up with someone else? Right? 2 can pair up with 6, right? 2 can pair up with 6. But if I increase my I, then it means that 2 cannot pair up with anyone else, which is not true. So I cannot increase my I, right? Because if I increase my I, it will mean that 2 cannot pair up with anyone else. If I decrease my j, it will mean that 13 cannot pair up with anyone else, which is true actually, because 13 cannot pair up with 2, right? And since this array is sorted, we know that every element after 2 is going to be greater than 2, right? So 13 cannot pair up with anyone after 2, right? And if it cannot pair up with 2 only, that how can it pair up with anyone after 2, right? So I can simply say that if my sum is greater than my limit, then I'm going to reduce my j and I'm going to increment my board count. So if my board count was 0, I'll increment it by 1, because this element is now going to go alone, right? This element is now going to go alone. Okay, so if my sum is greater than my limit, I'll decrement my j and I'll increment my count, right? It means that the heaviest person, which is at the last position, is going to go alone, right? It cannot pair up with someone else. Now we have I and j again, right? I and j are 2 and 11, right? Which gives me 13, which means that these two people can go together on the boat, right? 11 and 2 can pair up and they can go together on the boat. So I'll increment my I and I'll decrement my j, because these two people can go together on the board and I've included them in my answer. So I think if now my sum was less than my limit, so I'll increment my I, decrement my j, and I've used one board, right? So I'll increase my count by 1 only. So I'll increase my count by 1. Now the same goes for sum is equals to my limit, right? If my sum is equal to the limit, then only I'm going to increment my I and decrement my j and save the count plus plus, right? This is going to be the same as this. So instead of writing two conditions here, I can just simply say while sum is less than equal to my limit, and I can remove this one. Okay, and I will only have these two conditions. Yeah. Okay, so now let's put this here. Okay, so when I included 2 and 11, right? I included 2 and 11. I included these two. So I'm going to increment my I, decrement my j, and increase my count. Okay, now I have 6 and 11, 6 and 10. Now 6 and 10 gives me 16. which is greater than my limit. So it means that these two cannot go on the board together. I'll decrement my j. Right? If I decrement my j, then this 10 will go alone on the board and I will increase my count to 3. Right? Now I have 6 and 9. 6 and 9 will give me 15, which is also greater than my limit. So it means that j will also decrement again. And my 9 will go alone. Right? 9 will go alone. And I'll increase my count. Okay. So now I have I and j. Now 6 plus 8 gives me 14. So it means that I and j can go together now. Right? I and j can go together. So I'll increment my I, decrement my j, and include these two. So 6 and 8 are going together, and also increment my count, which is 5. Okay. Now I have I and j again. I plus j gives me 15. Right? 7 plus 8 gives me 15, which is greater than my limit. So I'll decrement my j, which means that this 8 will go together, or this 8 will go alone. Right? This 8 is going to go alone. Now I have I and j, also this will increment. I have I and j, right, which is 7, and now 7 and 7, which will give me 14. So these two are going to go together. So I'll increment my I and decrement my j, right? After which I will get my answer, right? Since these two intersect each other now, uh, this count will also increase to 7, right? So I've gotten my answer, which is this pair 1. This is a single pair 1, right? Let's remove I and j. 1, 2, 3, 4, 5, 6, and 7. Right? These are my total 7 boards that I've used to fill these people on the board, and I've used the minimum number of boards as 7. Okay, so this is my approach. It's a very simple question. Okay, now let's try to code this. Okay, so what are my steps? Let's write the steps first as abstraction. First, I'm going to sort the vector. Okay, and second, I'm going to use the 2-pointer approach. So first thing first, let's say I is at 0 and j is at the end -1, right? So people dot size -1. Now I have to sort the vector. So to sort, I will have sort of people dot begin, right? Then people dot end. So I've sorted the vector now. Now I will use the 2-pointer approach, and I also need this count, right? I also need a count or board count. So first I will have a while loop which will run from I is less than equals to j. Why less than equals to? Because I can also have a condition where I have a single element left, right? Maybe my I and j were equal at this moment. So this 9 will go alone on the board, right? So that is for that case also. I also need to handle that case, right? So while I is less than equals to j, here I will find the sum, which will be people of I plus people of j, right? Now I have the value of sum. Now I will check that if sum is less than equals to my limit or it is greater than my limit, right? If it is less than equals to my limit, then I'm going to increment my I, decrement my j, and increase my count. Hence, I'm going to only decrement my j and increase my count, right? And after this loop, I just need to return my count as my answer. And this is my total answer. Okay, so what are the steps? I first sorted the vector, then I've used the 2-pointer approach where I is at 0, j is at people dot size -1. Then I found the sum, which is the value of people, the value of the weight of people at I and the people at j, and I've calculated if sum is less than equals to limit. If it is, then these two people can go on the boat. So I'll put them on the boat and I'll increment my count. Right, I've used one boat. Now else it means that my sum is greater than my limit. So I've decremented my I and decremented my j, and I've increased my count because I've used one boat for that one person. Okay, and after that I've just returned my count. So let's run this code. It's successful. Let's submit this. Okay, this looks fine. So I hope you understand this question. If you don't, I would suggest you watch the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.